Okay, so today we're going to talk about reflections. We just talked about translations, again, slide. Now we're going to talk about reflections, commonly known as flip, right? So you've done all this. You've just used baby names for it. A reflection, just like looking in the mirror for a reflection. This morning I noticed a spot on my jacket, and I'm looking in the mirror trying to get it, and I can't because my hand keeps going the wrong way. Don't you hate that? You know, So reflection, we have to think that it's actually kind of going the opposite way. Line of reflection, well, that is what you just did a bunch of when we did that practice. You drew a line of reflection, a line that we're going to reflect something over. Glide reflection. A glide reflection is actually two things. It is a translation combined with a reflection. So kind of like that composition thing we had in the homework where we had two translations together. Unfortunately, this one we can't just add the numbers together. So that is really the difference between doing this in geometry and when you did it in elementary school. In elementary school, you just did one thing. You flipped it, you slid it somewhere, you turned it, whatever. One of our jobs by the end of the chapter is to figure out, does it make a difference if I translate it and then reflect it, or if I reflect it first and then translate it? And same with all the other things. What if I translate and rotate, or rotate and translate? Does it matter? No. What if I reflect and rotate, or rotate and reflect? Does it matter? Some of them do, some of them don't. And also, for instance, if I translate and translate again, I could just add those together and do one thing. But if I translate and I reflect, I can't just add those together. So we'll see how all that goes. Then this is just technicalities, but I wanted to point it out. There is a difference between asking about line symmetry and talking about the line of symmetry. The line of symmetry, again, is the line that you're flipping something over. That's the line you're using. But line symmetry is just a question about a thing. For instance, down here at the bottom, they're going to ask us if these things have line symmetry. In other words, is there a line that you could like fold them on? Okay? So there's a difference between the line of symmetry that you're going to flip something over and then line symmetry, which is just asking you, is there a place you can flip these things or fold them? Yes. And like get them to be exactly the same. Like when you used to fold the paper in half and then cut out the heart. You know? Okay. All right. A reflection is another transformation that uses a line like a mirror to reflect a figure. The mirror is called the line of reflection. A reflection in line M, and I know that sounds really funny, we would normally say over. If you're going to reflect, you're going to flip it over. But this is just the wording they use. A reflection in line M maps every point P in the plane to a point P prime. So did translations. So that for each point on one of the, so that each point, one of these properties is true again. So either P wasn't on the line you're flipping it over, so the M, the original point, is the perpendicular bisector of PP prime. We'll talk about that in a second. Or if your point is on the line you're reflecting, then it winds up equaling itself. So here's what they're talking about. Here's the point I'm reflecting. Here's the line I'm reflecting it in. And so I will use that terminology, even though it sounds weird. Here's what I'm reflecting. Here's what I'm reflecting it in. Here's where it's going to wind up going to. So this point reflected over to there. So it's telling me if I connected those 2 points, that line connecting those points should be the same amount on one side as it is on the other. And that's really important. If I flip something over the line and it was 3 spaces away from the line on the left, when I flip it over, now it should be 3 spaces away on the right. That should stay the same, right? Plus, if I do flip it over, the line connecting the two should be perpendicular to the thing I'm flipping it over. It shouldn't flip at an angle. Like something that's in the lower right-hand corner, if I'm flipping over to horizontal line, shouldn't wind up in the left-hand corner. That's weird. It should go straight up from it. Then this one is just saying, say I had a triangle. Triangle A, B, C. And I want to reflect it over this line. Well, if I do, I wind up with triangle, it should look the same size, A prime, B prime, C prime, but A and A prime are the same point. So that's all it's saying, is that if something is on the line, then it equals itself, and I'm not even sure how to label that then. It was the original A, but it's also A prime, so that's kind of weird. But this is really the important stuff. Something. Or maybe draw an arrow for both of them to that, I guess. I don't know. All right, so here's the tricky stuff then. What's here? Yeah, and then C and C prime are the same point. So that's why it would be really hard to show. Yeah. So I want to think about these a few minutes. If AB is reflected in the x-axis, again over, then its image is the point, So we have to think about this a few minutes. What's going on here? So if I have a point, oh, and here's the really tricky part. I don't know if one of these is positive or negative. Just because there's no sign doesn't mean they aren't. This could be 2, -3. It's just AB. So let's graph 2, -3. And let's reflect it over the x-axis. So if I do, ooh, this worked really well yesterday. I took my gel pen because when I folded it on the line, you know what happens with the gel pens. Yeah. And so did I fold it on the line real well? No, I didn't hit perfectly, but it's kind of close. But what I was saying before, if this is 1, 2, 3 spaces below the line, then this one better be 1, 2, 3 spaces above the line, right? But that's the idea, that it flipped to there. It just didn't fold it on the line very well. So if I started with the point 2, -3, now I'm at the point 2, 3. So if I'm now at the point 2, 3, what happened? Well, the 2 stayed the same, but the 3 changed signs, didn't it? And that's what this means, is opposite sign or changed sign. It doesn't mean it's negative. That's the tricky part of this. It does not mean that it's negative. It just means change whatever sign it was, just like an opposite signed reciprocal. So now, what if AB was reflected over the y-axis? So same point, and now I'm going to try to fold it there. Again, I did a little better job of folding it, but same thing happened. And if it's 2 spaces to the right of that line, now it should be 2 spaces to the left. So my original point, 2, -3, has now become -2, -3. So what happened there? Yeah, now the A changed signs, but the B stayed the same. So let's back up and look at that for a minute, because that's the same thing that was confusing Jake when he was awake before. That if I reflected over the X, I changed the sign on the Y. If I reflected over the Y, I changed the sign on the X. Wow, rules are a pain, aren't they? So if she says no, she means yes. No, that is not true, so sorry. Okay. Then, what if I reflect over this line? Well, first question is, and we graphed it this morning, where is the line where x and y are equal? It's that one, isn't it? That's the line where x and y are equal. Y equals x. So, if I take this same jelly point and I flip it over that line, it turns up here. Is that, yeah, that's kind of weird, but that's what happens. So let's see what happened. We started with 2, -3, and now it's at -3, 2. So what happened there? Yeah, it just became BA. Did the signs change? -3 is still a -3, and 2 is still a 2. So it didn't have anything to do with the signs, it was just the letters. So if x and y are equal for the line that I'm graphing it over, it just flipped the things around. That's probably why it's so hard to find that piece of lint when you're looking in the mirror, because it's going backwards than what you think. And then finally, if I take 2, -3, and I flip it over this line, didn't hit that perfectly, but that's our line y equals -x. So I'm going to take this point and I'm going to flip it over this line, and now it winds up right there. Thank goodness for gel pens. So now where is it? Now it's at 3, -2. So now what happened? Everything, right? Everything. So the letters switched place. A became B and B became A. The -3 became a positive, so it switched signs. The +2 became a negative, so it switched signs. So these two are really important to realize then. So if you're going to reflect over the line x equals y, the letters switch places, or the numbers switch places. If you're going to do x and y and -x, then not only do they change places, they change signs. So those are your rules that you can use. And I'm pretty sure on the test, I put those at the bottom of the test. They're not something I expect you to remember. But I don't know about an error test. Okay, so let's take a couple of quick minutes and look at lines, symmetry lines is really what I would say. I wouldn't say line symmetry. I would say symmetry lines. I want lines that I'm using. So can I draw a line either horizontally or vertically through moon? And like if I had a gel pen, would that happen, that it flips over? No. Because if I go this way, the M and the N aren't going to be the same, are they? And sadly, even though O's have line symmetry that way, the M wouldn't, would it? So no, there's no line symmetry here. Is there line symmetry in wow?
Yeah.
Horizontal or vertical? Vertical, right through the center of the O. Well, that wasn't good. Right through the center of the O. So if I flip that over, the W and the W, couldn't tell the difference. How about a kid? Can I cut a kid in half?
Horizontal.
Oh, I can cut a kid in half horizontally. Okay. I will do that. Mark's looking at me like, you're strange. So the top of the K and the bottom of the K are the same. On the computer they are. Back in the day when I was taught to make them, a small K was not the same at the top and the bottom. But then there's computers. Yeah, the top line was supposed to be smaller, not some weird thing. So you guys did have handwriting? Oh my gosh. Okay. How about dock? Can I cut dock in half? Horizontal or vertical? Horizontal. Can you think of any more words that might have vertical line symmetry? Well, of course, if wow works, mom works. So mom would have horizontal symmetry. What about Bob?
Yeah.
Bob would work. Okay.
Back.
Yes, if it was capitalized. Or same with hack. I thought you said hack. But either of those, if it was capitalized, then I think that would work. that we could do this way.
So you can use the A.
Oh, that's true. Well, then what about O? There we go.
Hot.
Hot.
Okay. All right. I don't think I'm going to work every one of these, and I'm sorry it looks kind of sloppy. My computer just did not want to put this stuff in. But as I said when we were checking yesterday's homework, it is a good idea to do the math first and then plot the new point. A few things, like if you're reflecting over a horizontal line, yes, you can just count. If it's 2 below the horizontal line, you're going to make it 2 above the line. Or if it's a vertical line, if it's 3 to the left, you're going to go 3 to the right. I get that. But sometimes it's not that easy. So if we're going to reflect over the y-axis, well, first thing we need to do is plot our triangle here. So negative 1, 5, there's A. B is at negative 4, 4. And C is at negative 3. Oops, I missed something on there. 1, 2, 3, 4. B should be there. There we go. And then 1, 2, 3,
Same with A.
1. Am I off on A too? Because it's not 1, 2, 3. Yuck. Yeah. Because it's only a 4 by 4 graph instead of a 5 by 5. This book drives me crazy. And be very careful about the ones where they're counting by 2. So if I'm reflecting over the y-axis, yes, I can just count. I could count from the y-axis and see how far away each of those points are, but that's what we've got rules for. To reflect over the y-axis, we said that we're going to switch the sign on the x. So these points then, if it was a negative 1x, now it's going to be a positive 1. A negative 4 is going to be a positive 4. And a negative 3 is going to be a positive 3. And the y's are going to stay the same. Then if I graph my new ones, because really the graphing's getting to be kind of tedious, isn't it? And that's really not the ultimate purpose. It's good to see. It's good to see the reflections, but sometimes, you know, it's easier just to do the math. So 1, 5 would be there. That's my A prime. 4, 4 is my B prime. And 3, 1 is my C prime. And now, now a rigid motion. It is the same shape. It is the same size. It's just not facing the same direction anymore, is it? Translating stays the same direction. This one, it's facing the other direction. So your friend said something rude to you, and you turned your back on him. Okay. Next one, we want to reflect that over the x-axis. What's wrong? Oh, I'm so sorry. This one?
Her lines are just missing.
Yeah, I think it's so hard to see on the projector. The color is just awful. Is that any better?
Yeah.
Yeah, then it got a little darker. It's from using that calculator. Okay. Did that help a little? Okay. Okay, so next one, we have to graph this again. So 0, 2 is, I can't even see the lines there. 4, 5, 1, 2, 3, 4. So if this is only going there, there's B. And C is at 5, 2. Of course it is. So there's my triangle. And this time I'm going to reflect over the x-axis. So my rule is to change the sign on the y. So 0, negative 2, 4, negative 5, and 5, negative 2. Then graph that triangle. So don't go right or left at all, go down 2. There's A prime. Go to the right 4 and down 5. There's B prime. And go to the right 5 and down 2. There's C prime. again, same shape, same size, but it's been flipped over. And if it's 2 spaces above the line for the original, it's now 2 spaces below the line for the copy. Now it gets tricky. So somebody needs to wake up. About 3 people. In a diagonal there. Because now look what we've got. We're reflecting over the line y equals 1, and we don't have rules for those. There are only rules for those 4 basic things: the x-axis, the y-axis, and the 2 diagonals that go through 0. Those are the only standard lines. This one, the first thing we need to do now is draw the line. So you can look back at your notes that we did. I don't think we did y equals 1, but we did some like that. Or you could think, what's this saying about the point? It's saying the x can be anywhere, but the y is always going to be at 1. So this is the line I'm reflecting over. Might not be a bad idea to use a black pen or something heavy. Then let's plot our new triangle. So to the right 2, down 1, there's A. To the left 4, 1, 2, 3, 4, down 2, there's B. And to the left 1, down 3, 1, 2, 3, there's C. And this time, since there's no rule, there's really no math. The only thing we can do now is just count. If point A was 2 spaces below the line, now we have to go 2 spaces above the line. And that's why I want you to make that line dark, because the chances of using the x-axis, yeah, I've seen it. People don't really, they don't really stop and think. They're thinking count above a line, and they go for the x-axis. So this one, from this line, it's down 1, 2, 3, 4 spaces. So from this line, I have to go up 4 spaces. I'm up there off the graph. From this line, I'm going to go down 3 spaces, so now I'm going to go up 3 spaces and get B prime. But you would know right away if you made a mistake if it wasn't the same size and the same shape. But again, this one should be facing the opposite direction. So I do want to take a look at the points for a second. A is at 2, 1, 2, 3. B is at -4, 4. And C is at -1, 5. So something did happen. The x's stayed the same. When we reflected across the y, the x's stayed the same. The y's, there's no math for that. -1 became 3, -2 became 4, -3 became 5. There's nothing that those have in common. Okay. Again, I don't think I want to work all of this stuff, but let's just talk about this for a second. If I'm reflecting over x equals -3, horizontal or vertical, y was horizontal, so x is a vertical through -3. Yeah, this one I don't think will be too fun to reflect over, because if my triangle's over here, where's it going to go? It's going to be off the graph over here, isn't it? So yeah, this is going to wind up over here, kind of facing in the opposite direction. So that wouldn't be too fun. Then these two, again, we do have rules for those. And look what I did this time. This time, to make sure I'm accurate, since they didn't give me the points in numbers, I think it's best to list the points first, use the rule we have, and then plot the new thing. Because if you try to just think about how to flip that, I bet it's not going to work. So A is at -3, 2. X equals y told us to just switch the things around. So now it should be at 2, -3. B was at -1, 2. So now it should be at 2, -1. C is at -1, 1, 2, 3, 4. So now this graph has 5 spaces. And that means now it's going to be at 4, -1. And D is at -3, 1, 2, 3, 4. So now it's going to be at 4, -3. So when we flip this to the right 2, down 3, there's A prime, to the right 1, or sorry, to the right 2, down 1, there's B prime, C prime to the right 4 and down 1, and D prime to the right 4 and down 3. Well, that makes sense. It's a square. But look what happened. B is here, D is way out here, but C and A. So I don't know if you would have really thought about that if you don't use the rules for the points. Mhm. Yes, and I have your homework for you. It's just a review paper. Okay, last one real quickly. This time we're going to do, here's our original, we're going to do a glide reflection. That means 2 things. First, we're going to have to translate, then we're going to have to reflect. Again, you could just do that as rules. The translation, we know we just need to subtract 6, subtract 1, subtract 6, subtract 1. So we could go through and write our new points there. And we have a rule for this, so we could do J double prime, K double prime, L double prime. So we could use the rules to do all of those and then just graph the different triangles. And I did ask if you can on these to graph in 2 different colors, just so we can see where the different ones went. But this one then, you should see a total of 3 triangles on there. Okay. Homework, the good news is it's just A. I wouldn't scribble out B, but it's just A, 1 through 12.
Is this also due on Monday?
This is due on Monday.
Okay.
Well, no, for everybody else, we'll be checking this tomorrow. Okay. All right.
So this is